Another class with me. Today we talk about application of differentiation. And here is our learning target. And let's look at our questions. Now, here's the photos of a lantern of Mid-Autumn Festival. And assume that you are inspired to make this particular shape of lantern with a wire that is 1,200 centimeter. And assuming that you're not going to have any waste, you're going to make your lantern have this particular frame over here with this particular dimension. And first thing is that we need to express h in terms of x, and then we need to show that the volume is this, and then we want to find out what is the value of x if you want this to have a maximum volume, for example. Okay, so to get started, I will look at, well, in terms of y that we have 1,200 centimeters. And let's look at the length. Length, how many lengths do we have? Well, we have 4 of them. All right, so 4 of 3x. And then plus width, also 4 widths. So that's going to be x. So the 4 is out here. And then last thing, we have the h, the height. And in this case, we have 4 height as well. So that is 1,200 divided by 4, that would be 300, equal to 3x plus x, 4x plus h. Therefore, h itself is 300 minus 4x. And you can see that in this case, there is a common factor, 4. So you can take the common factor out 4, and then they will left with 75 minus x. So h can be expressed as this. So this is question number 1. Question number 2 say that we need to find the volume. Well, okay, so volume is equal to the length times the width times the height. This case is 3x, and the width is x, and the height is 4 times of 75 minus x. So that simplifies to 12x squared 70 times 75 minus x, exactly as we want. So as needed or required. Okay, so this is question number 2. Now question number 3. Now question number 3, in order to get the maximum value, I really need to take the derivative, so dv dx in this case. So I have to use the, so here's a product, so I have to use the product rule. So the first one will be 24x, that is the derivative of the first part, keep the second part constant, plus keep the first part constant, and then take the derivative of the second part. In this case, it's negative 1. So I will have 24x times 75. And then minus 24x squared, and then minus 12x squared. This is take out the common factor 12x. And then inside the bracket, I will have, in this case, 150 minus 25, minus 25 minus 12 is minus 36. So in this case, is 3x. All right, so I have this. And in order to find the maximum or minimum value, I need to set dx to 0. So to set it to 0 means that x can be 0, or 150 minus 3x is equal to 0, or x is equal to 50. So if x is 0, I'm basically not going to be able to construct a frame, so the volume here cannot be maximum. So the only answer is x equal to 50. Now, I can also verify this by doing the second derivative test. So I'm going to use this again. So the second derivative test, the 2v dx squared, so that will become 12. I have to use the product rule again. and then plus 12x times negative 3. So that will be 12 times 150 minus 36x, and then minus 36x again. And at the second derivative, when x is equal to 50, and you can see that this answer here is going to be negative. Therefore, I know then my volume now is a max. So that's the answer.